there's so many VMAX that don't have pictures on there, and it's like trying to scroll through so you guys the most videos.
Okay, so here we are, remainder theorem. It says, if a polynomial f of x is divided by x minus k, then the remainder is f of k. We actually did this in section 5.2. Let's look back at example 4. It said we wanted to divide by x plus 3, so that means f of negative 3 was negative 16. Okay, do you understand that? That's actually what we did in 5.2. And in example 5, we had f of negative 3 is equal to negative 9. Okay, it's just, so we did this before. If you know you divide by x minus k, then f of k is the remainder. Now what we're going to do is we're going to take this and apply it to the factor theorem. It says a polynomial f of x has a factor of x minus k if and only if f of k equals 0. That means if the remainder is 0, then x minus k is a factor. This is going to be very, very helpful, very, very important for us. So if you know the remainder is 0, then x minus k is a factor, but if x minus k is a factor, f of k was 0. All right, so let's see that in action. In example 6, it says factor f of x completely given that x plus 2 is a factor. Watch what I'm going to do. I'm going to do synthetic division. And when I divide an x cubed by an x to the first, it produces an x squared. So I'm doing the division to get it down to an x squared, and we know how to factor x squared, don't we? AC method, difference of two perfect squares, all that kind of stuff. So let's bring down the 3. That's negative 6, add the column. Positive 20, add the column. Positive 16, add the column. Notice that the remainder is 0. The remainder is 0 is just verifying that x plus 2 is a factor. But then what I've got is 3x squared minus 10x minus 8. I know how to factor that. I'm going to use trial and error. So if you like the AC method, we can kind of combine it here with trial and error. 3 times negative 8 is negative 24. I'm looking for two numbers that are going to multiply to negative 24 but add up to negative 10. Negative 12 and 2, right? Notice it can't be 6 and 4 because they have to be opposite signs. So that won't add up to the negative 10. So I'm going to put a 4 here and a 2 here. Do you see that's my 12x and my 2x, but I need the 12x to be minus. Now, if you were to circle this, 3x plus 2 times x minus 4, I would mark it wrong. Why?
Because it's an equation.
What do you mean by it's an equation?
It's f of x equals, so.
Okay, so first of all, I like what you said there. It's f of x, but do you notice if I multiply this out, it doesn't produce f of x.
Teacher's lounge from the hoods.
Okay, do you see if I multiply that out, it doesn't produce f of x? What's missing? There's something missing from here that would produce the whole thing. What? Another x. It told us x plus 2 is a factor, right? Oh, you've got to remember the original factor that was given. Okay? So Henry was absolutely right there when he said, well, it's f of x equals, we need an f of x equals, but it's got to multiply to give me an x cubed. Yes, I found the remaining ones, but I needed to completely factor f of x. Alright, so we're going to do example 7, then I'm going to ask you to go to your warm-up section, or where you can do extra practice, and we're going to do 2 more of these. Alright, it says factor f of x completely given that x minus 3 is a factor. So what we're doing is we're going to do synthetic division. You could even do long division if you wanted. And we're taking it from an x cubed down to an x squared that we know how to factor. Alright, so you bring down the 2. 3 times 2 is 6. Add the column. 3 times negative 5 is negative 15. Add the column. 3 times negative 12 is negative 36. And I get 0. Now let me ask again, what does it mean when the remainder is 0? That means x minus 3 is a factor. So here's a helpful suggestion. If you do this and it said x minus 3 is a factor and you got, say, 2 in here or some other number, you've made a mistake somewhere and you need to go fix it. All right, so now I'm getting 2x squared minus 5x minus 12. All right, now go ahead and factor that. Okay, I got 2x plus 3 and x minus 4, but that would not be the correct answer. It says completely factor f of x. So I need to include the f of x equals, and I need the x minus 3 times 2x plus 3 times x minus 4. Okay, so let me go over what we're doing here one more time. If you know a factor, you can find the other factors by doing synthetic division and dividing the polynomial down to a quadratic, and then we can do quadratic factoring. All right, so go to your warm-up section, and I want you to try this one on your own. Let's see if we're really getting the hang of it. It says factor f of x equals x cubed minus 6x squared plus 5x plus 12 completely, given that x minus 4 is a factor. Alright, did you guys get f of x equals x minus 4 times x minus 3 times x plus 1? Alright, one more. Factor f of x equals x cubed plus 2x squared minus 51x plus 108. Factor it completely given that x plus 9 is a factor. Alright, did you get f of x equals x plus 9 times x minus 4 times x minus 3? Did you also notice that even though I had this minus 51 and 108, it wasn't horrible? Like, I know that sometimes students will overreact and say, oh, there's big numbers, I can't do that. You know, these really were not horrible for you to do. Okay, then back to the notes. What we've done so far, again, is looked at the factor theorem, that if we knew a factor, we could reduce it down to a quadratic and continue to factor it. Then the natural continuation in example 8 is, okay, what if I have a 0 or a solution? Remember the word 0 is another word for solution or x-intercept. So if x equals 3 is a 0, now let's go back here. If x equals 3 is a 0, that means f of 3 is 0. That means the remainder is 0. So what do I know? What can I infer from that factor theorem? If you know the remainder is 0 at x equals 3, what can we conclude? X minus 3 is a factor. Okay? X minus 3 is a factor. Well, if I know a factor, I can divide it down to a quadratic, and then I know how to factor and solve. So we're just adding one new step here. So I'm going to put 3 in the box. And I'm going to divide this down to a quadratic, which I'll factor. And now the new thing is we're going to set them equal to 0 to find the zeros. Now it's a good thing my remainder is 0. That verifies that x is a 0. So then I'm getting x squared plus x minus 20, but I'm being asked to find another 0, another solution. Well, this one factors easily. X plus 5, x minus 4. So another 0 would be negative 5 or positive 4. Do I have to list x equals 3? No, because of the wording. It said, what is another 0? Now, I'm never ever going to try to trick you guys, but I am going to ask to make sure you're reading your problems carefully, because that's a good life skill to have. If it said, what are all the zeros, you would include the original one given, okay? All right, let's try example 9. 1 0 of f of x is 4. So that means f of 4 is 0. So x minus 4 is a factor. So we're going to put 4 in the box and divide the x cubed down to an x squared. And then use factoring to find the other solutions or zeros. Okay, so you should be getting x is negative 4, x is negative 1. All right, now go back to your warm-up section, and I want you to try this one going all the way through on your own. Let's see if you really do have it. 6 or x is negative 1. You guys got it? Okay, let's do one more and then we'll go back to the notes. Okay, try this one. And I want you to notice the difference between these two and the previous two. If you're asked to factor, there's no solutions. But when you're asked to find zeros, there are solutions. Yeah. So wait a minute, that didn't add up, right? Sorry about that. Woo. Okay. Ooh, this one's harder to factor. How about negative 15 and 4? You see, here's my 15x and my 4x. So x is negative 2/5 and x is 3/2. If you're struggling with the factoring, you need to come in at lunch and get some extra help to get that ironed out, because that's now a skill that's assumed you're proficient with. And if you're not, that's a problem, and you need to take care of that problem, and I'm more than happy to help you, but I'm not going to reteach it again during our class. All right, last problem. Here's an application to what we've been doing. It says the profit P in millions of dollars for a, and that's supposed to say for a shoe manufacturer, can be modeled by P equals negative 21x cubed plus 46x, where x is the number of shoes produced in millions. The company now produces 1 million shoes and makes a profit of $25 million, but would like to cut back production. What lesser number of shoes could the company produce and still make the same profit? Well, the profit is in millions, so the profit is 25. And what they're telling us is that when the profit's 25, x equals 1 is a solution. Okay, x equals 1 is a solution. So what I'm going to do is I'm going to bring everything over to the left side. And I'm going to use that x equals 1 as a solution to still divide it down to a quadratic. So I'm going to put 1 in the box. So I bring down the 21. And I'm getting the quadratic equation 21x squared plus 21x minus 25. And I'm trying to solve this. Well, I don't want you to spin your wheels or waste any time. It does not factor, okay? So we have another tool in our tool belt that allows us to solve a quadratic equation when it doesn't factor. What tool is it? The quadratic formula. And in this case, because the numbers are going to get really big, we're going to use the program. Okay, that's a good thing. So go ahead and take out your graphing calculators. Let's see if mine's on here still. So here's program, quad form. We have 21, 21, negative 20, was it negative 25?
Yes.
Okay, thank you. So I'm getting two answers here. Notice our program also gives the discriminant. That's like, what's under the square root. Now, you can't have a negative number of shoes being produced, so only the 0.7 makes any sense. Now, that's 0.7 million shoes, or 700,000 shoes. And what's interesting here is that an x cubed graph, you're going to learn about this later. No, we did it a little bit. Remember x cubed with our arms? This is something like there's some kind of a wiggle, maybe, and that there's at least two places where it's hitting 1. It was at 1 and at 0.7. Do you see that? I mean, that's the connection to the graph, to that. All right, that finishes our lesson.